battlefield.
In recent years, companies like SpaceX and Rocket Lab have lowered the barrier of entry to space, supporting all kinds of new technologies, including microsatellites. These microsatellites can get down to the size of a loaf of bread, and they are revolutionizing how we use space to impact life here on Earth. In fact, in the next 10 years, almost half of all satellites will be microsatellites. They are tracking global climate change in real time, enabling the next generation of IoT connectivity, and even providing vital insight in the wake of natural disasters. But for the companies that use these microsatellites, getting to space is just half the battle. Because they are forced to ride alongside dozens of others, they must compromise on every aspect of the launch. To start, these customers must pick from preset schedules of launches. Often they are forced to schedule a launch up to a year and a half in advance. Each scheduled launch also has an assigned destination. And these satellites are often forced or dropped off far from where they want to be and must spend upwards of 6 months slowly moving to their final orbit. And finally, integrating so many customers onto one launch is incredibly complex. And this introduces a number of restrictions that limit what satellites can do. Adding up all these pain points can lead to 2.5 years between when a launch is scheduled and when a satellite is operational. And while these companies are waiting, they're burning capital, deferring revenue, and adding to a growing backlog of satellites that are just waiting to get to space. This model is what the space industry calls ride sharing. Microsatellites have to literally share a ride to space. But what customers need is the experience that you and I know as ride sharing, where you can call up a ride that takes you where you want to go, when you want to get there, no compromise. And at Leo Aerospace, we are fundamentally committed to providing our microsatellite customers with the dedicated launch service that they've been asking for. And this all starts with the vehicle. Now, in creating a vehicle to provide this type of service, our first thought was to just shrink the rocket down to match the size of our customer. The problem is, when you launch a rocket from the ground, you can only make it so small while still having enough energy to reach orbit. And unfortunately, at this size, it's just too big and expensive. One of the reasons for this is due to atmospheric drag. And so if you could launch your rocket above 95% of the Earth's atmosphere, you could make it small enough to cost-effectively launch an individual customer. And that's exactly what we do. Introducing Leo Aerospace's premier high-altitude launch platform, Regulus. Regulus is a fully reusable and autonomous vehicle that allows us to launch rockets from 60,000 feet in altitude. By launching at this altitude, we can reduce the size of the rocket to just half of what it would be if we would launch it from the ground. Let me show you how it works. Regulus is fully mobile and fits into a standard shipping container. A series of burners ignite, heating the air within the balloon envelope. The hot air balloon carries Regulus away from the transport truck. Regulus is capable of fully autonomous controlled ascent. A sensor suite on board allows it to ascend to its final altitude of 60,000 feet without human control. Our proprietary rotational control system activates. This orients the launch platform and stabilizes it during the launch sequence. Our first stage ignites, launching the rocket from the platform. Our first and second stages use a solid motor architecture. This architecture is safe, it's shelf-stable, and it's mass manufacturable. Inserting each satellite into its precise orbit is vital. For fine-tuned control, we use a third-stage non-cryogenic liquid propulsion system. Because we tailor each launch to an individual customer, they can begin operating their satellites immediately. And while the rocket is deploying the satellite to orbit, Regulus descends autonomously back down to the ground. Here, another rocket can be loaded for another launch, or it can be all packaged up and shipped home. With this platform, Leo Aerospace can provide a launch within a matter of weeks to any low Earth orbit and support a very high launch frequency. Finally, microsatellite customers will have the dedicated launch service they've been asking for. Leo Aerospace made history in 2018 as the first and only company to receive authorization from the FAA to launch a high-powered rocket from a reusable balloon platform. This series of successful launches validated major subsystems and also provided a clear regulatory path for us moving forward. And while we were testing these systems, we realized that our platform could do more than just launch rockets at altitude. And that's why we are working with NASA JPL to assess how our technology can be used as a testbed on the path to Mars. We are working to flight qualify our platform next year up to 60,000 feet, and this opens the door to a $2.6 billion high-altitude platform services market. LEO Aerospace is under contract with the US Air Force, and we have identified over 100 scientific payloads in their backlog. We are working to launch the first of these in our suborbital launch test also next year. This milestone also provides validation to our commercial customers and allows us to begin taking contracts for orbital launches. Finally, we will launch our first payload to orbit in 2022, opening the door to a $5.6 billion associated launch market. As a team, we bring experience programming flight operations software at NASA, performing propulsion work on the James Webb Space Telescope, and leading combat operations as a US naval officer. Go to leoaerospace.com. Join us on our mission to revolutionize access to space. With that, I'd like to leave you with some footage from one of our recent tests. Thank you.
Cool. Okay, judges. Ryan, go ahead.
Well done, guys. What is the payload range you're targeting, and what is the cost per kilogram for launch to a sun-synchronous or any other orbit?
Yeah, of course. So our baseline payload capacity is 25 kilograms to a 550-kilometer sun-synchronous orbit. That's what all of our markets and numbers are based off of, so the smaller end of the satellite market. In terms of the price per kilogram, we're looking to price competitively with current rideshare models. But in conversations with our customers, they've made it very clear that the sort of dedicated launch where they can pick where and when they're actually going is a premium service in their eyes, and they're willing to pay more for that.
We've looked at a variety of space tech companies, kind of broadly defined, and have been hesitant to invest because of the capital intensity of the category. And typically, you need hundreds of millions of dollars, maybe even more, to kind of get to scale. Do you guys have a sense of what type of capital you guys are going to need, not just to kind of get some of the initial tests done, but actually, get the product actually working, get through all the science risk? These are typically multi-year sales processes into the government that's really, really long and expensive to get them to engage. So what is the actual kind of scale of capital need to be for you guys to be successful?
Yeah, I'll let Bryce take that.
Yes, so you're absolutely right in the fact that space tech companies are generally very capital intensive. Most space launch companies have raised on the order of hundreds of millions of dollars prior to getting to orbit. Rocket Lab raised $288 million, Relativity just closed $140 million, Vector had raised $107 million. And so with our projections, though, we foresee being able to get to orbit on the order of tens of millions, not hundreds of millions of dollars. And we have made strategic decisions to enable us to actually pull that off. For example, for any standard launch program, 70% of the R&D cost goes into the engines of that program. We are not building our own engines. We are sourcing those from industry suppliers. We have great relationships with those suppliers who are already building up facilities to be able to support our needs. And with regards to your question about multi-year sales cycles for government, things like that, we are already actually writing contract proposals right now with the US Air Force with identified customers and end users who are begging for our technology to be able to pull off suborbital launches next year.
Could you maybe walk us through what is it that is most proprietary about your system or platform versus where you're using existing components and parts?
Absolutely.
Techniques?
So a lot of our proprietary technology comes in the integration and operation of high-altitude balloon and rockets together. It's a complex problem. For example, the US Air Force tried doing it back in the 1950s, and they successfully did it. But the way that they did it was by launching the rockets through their balloons, exploding it. It was non-reusable, and it was pretty hazardous. In order to do this autonomously and reusably, there's a lot of proprietary technology in there that allows us to do that.
You guys, obviously, to get to 60,000 feet launch is, it's probably not tomorrow. How long do you guys think that's going to take? And what are, in lieu of revenues, what are the KPIs that you guys are tracking that you think are most important in your journey to get to the 60,000 foot launch?
Absolutely.
Yeah, so to address the timeline, we're looking to get up to that 60-foot launch early to mid next year. In terms of the KPIs that we're tracking, there's obviously a lot of development and technical milestones and different testing programs that we work in partnership with the FAA's Office of Commercial Space to safely license the vehicle both in parts and as well as when it's together. And in terms of other KPIs, we're also focused on 3 different customer segments. Commercial, defense, and civil is how we think of those 3. And so they each obviously have very different sales cycles, and we construct KPIs in regards to each of them.
Other questions?
I guess, is there any environmental issues? Just like, on the one hand, you talk about sort of convenience and predictability, but I imagine balloon launching is very dependent on kind of weather and climate. So, how do you have any sort of confidence level that you can hit the windows based on the sort of dependability that you have on the environmental factors?
Yeah, so environmental conditions are always a factor, for any launch vehicle. And so our system is designed to fit within the bounds of any sort of environmental factors that you would typically see with a launch vehicle.
But to add on to that, because our platform is entirely mobile, if we know that, say, there's a hurricane coming up with Florida, that's going to postpone any launches happening from Cape Canaveral, well, we can move to the West Coast and launch from there. Or we can move to Australia, or New Zealand, or Europe, or literally anywhere with the system, anywhere that you are licensed to fly in the airspace. Obviously, we work with all local governments, but I mean, we can even fly this thing off of large barges and things like that.
Can I ask one follow-up question?
Yeah.
How much will it cost to get the first rocket in space with your first paying customer?
Answer quickly.
Yeah, so that's the largest cost, the non-recurring engineering going into developing and regulating and licensing that vehicle. The costs severely drop off after that.
Is it 10 million, 50 million? Like, what is it to actually have like a real revenue-producing customer?
I will say tens of millions. Yes, low tens of millions. Happy to discuss that offline.
All right, give it
very
up for Leo Aerospace.